Good morning, good afternoon, good evening, depending on where you are. Welcome to this 8th webinar on CPT. We'll talk today about what equipment is needed to perform CPT. Let me introduce to you Troy Chips, the CEO of Eijkelkamp North America. Troy, the floor is yours.
Thanks a lot, Gerald. I appreciate it. Well, hello, everyone. So I can't believe it's already the 8th webinar this year. And as you can see on the screen, it's titled, What Equipment is Needed to Perform CPT? And as Mike and Gerald have a conversation of what's needed, I'd like to turn it back over to them now. Mike is he is our Eijkelkamp North America Regional Sales Manager. He's located in Austin, Texas, and Gerald Verbeek is our ENA Technical Advisor for CPT and GeoPoint Solutions. With that, guys, take it away.
Well, good morning, Gerald, and thank you, Troy. As we've done in the past, these questions have been given to Gerald in advance, and we hope that you'll have questions during and after these topics. Thank you for joining us. So with that, I'd say let's get started. And the first question is, and maybe I should say first that my background. This is my 31st year in the drilling industry. My background has primarily been in top head drive drilling rigs. So CPT has been certainly a learning curve for me this last 12 months that I've been with Eijkelkamp. The first question is, with so many options, there's several options for downhole downforce between 9 ton and 30 ton. What is right for my job or my client?
Okay, thanks, Mike. And once again, welcome everybody. What is the right option? That's a difficult question to answer because obviously it depends from client to client. But my general recommendation is start small and transition to bigger equipment and try to utilize the equipment that you have as wisely as possible. Let me explain to you what I mean by that. Most of you, since you are involved with Eijkelkamp, and as Mike was saying, therefore most likely involved with drilling, you will have a drill rig. And then instead of starting out with a completely independent standalone CPT unit, you could easily start out with what you see here on the screen, the drill and CPT, which is a unit that you can connect to your drill rig. It's a relatively small investment because you don't have a completely standalone system, and then the hydraulics of the drill and CPT can be taken from the hydraulics of your drill rig. And then once you feel more comfortable with this whole thing, you might go to a standalone little crawler. Obviously fairly lightweight. You will have to still do some anchoring, as you can see here. This unit has been anchored in the ground with some ground anchors. Or if you feel really encouraged, you might also go to a completely heavy 20-ton box crawler so that you can do virtually all your CPT itself. As you are going from left to right, the investment increases. The system still remains the same, but obviously it takes more money. So that's the first thing. Start small and then transition to bigger equipment. But the other important thing is consider in what types of soil you want to use it. And the reason that I mention that is, for those of you that have been attending some of those previous webinars, you've seen this graph on the right-hand side. If you have large equipment, generally speaking, you have more dead weight, more ballast weight, and you can push the cone deeper. Most of you are familiar with the N values, so that's why I came up with this chart, because it now shows on the bottom horizontal axis the N values. And if you are normally doing your work in, say, an N value of 50, 40 to 60 in that range or so, then you see that you will need a unit that has basically a capacity of about 10 tons. You don't necessarily immediately need to go to a unit that can push 20 or 25 or even 30 tons. And that's, I think, very important, because if you are generally working in soils that are softer, then you can get a feel for what kind of pushing capability you would need. And then finally, what I think is important is consider the 80-20 rule. When you get involved with this, don't necessarily buy something straight away that will give you the capability to do all your CPT work that you can possibly encounter. If you every now and then are working in soils that have a higher N value of, say, 80, where you would need more than the 10 tons that we just talked about, say, okay, fine. In those cases, you hire a subcontractor or another provider to do that CPT for you, or don't bid on that job, but at least give you something that allows you to do most of the CPT that you will get involved with, but not necessarily all of it. So those are kind of the items that I would suggest. Start small, move to large equipment, but also keep in mind what types of soils you have, and then the electrical CPT system itself, the cones, the rods, irrespective of what kind of equipment you buy or you begin with, you can utilize it at all times. Does that kind of answer your question, Mike?
Yeah, it sure does, Gerald. And I think it, you know, that 80-20 rule is so true in so many parts of our life, but understanding and knowing your market will help you lead you to the right piece of equipment. So no, that's excellent. And that leads me, though, also to, are all cones created equal? There's a lot of people that just make cones. Can you tell me a little bit more about cones?
Oh, I can talk about cones for a long time. The simple answer is, of course, no, not all cones are equal. Just like not all people are equal, not all organizations are equal. There are always differences. But let's look at it, instead of talking about one product over another, let's look at it in general terms, and come up with something that is important for people that get involved with CPT, to at least understand what these cones are all about. First of all, what you see here on the right-hand side of the screen are a whole bunch of different cones. And as you can see, the diameter gets larger and larger when you move from left to right. We start out with a very small cone that is basically only used for lab testing. And on the right-hand side, we have the 15 centimeter square cone that is utilized in a lot of places in the industry. Most of the time, though, we were talking about the 5, 10, or 15 centimeter square cone. And for those of you that are not familiar with the terminology, it is basically the cross-sectional area or the base of the cone, or the cross-sectional area of the cone itself that is expressed in centimeter squares. And if you are talking about a 10 centimeter square cone, you have a diameter of 1.44 inches. And if you have a 15 centimeter square cone, it gets you a diameter of 1.75 inches. Basically, the diameter changes. And if we go back to the slide that I showed you a little bit earlier, you will see on here that we're talking here about a 15 centimeter square cone with slightly smaller rods, smaller diameter. That gets you the deepest. So in a lot of cases, I would say go for the 15 centimeter square cone. It's a robust cone, it's a strong cone, but diameter is obviously plays a role, and that's why not all cones are the same. A little bit more complex is there are different types of cones, how they work. The compression versus the subtraction cone. To summarize something that I talked about some time ago, what you see here are two schematics. On the left-hand side, the compression type cone, the right-hand side, the subtraction cone. And the reason that we call them by that name is probably the easiest explained with the subtraction cone. So let's look at that. What you see there, you have your cone tip, which is indicated by the number 5, and then above that is a load cell that measures the load on your cone tip. And then above the cone tip, you have your friction sleeve that is put also, of course, load on there. And you then have a combined load cell over here that measures the total load. And that means that this is the load measured over here of both your sleeve and your tip. And if you then subtract the load that you have measured here for just the tip, then you get your reading for your friction sleeve. So that's why you have the term subtraction cone. In the compression cone, it's different. We have a load cell for the tip, and we have a separate independent load cell for the sleeve. So there's no subtracting there. But what you see already here is that a subtraction cone is a little bit more robust. It's easier because everything has been completely incorporated, and the load cells, you don't need separate load cells. They're all in one body. It looks more robust than what you see on the left-hand side for the compression cone. And that's important. If you are in a little bit more uncertain, if you're more careful of damaging your cone, because let's face it, you can damage your cone, the subtraction cone is more robust, less prone to damage, and therefore a little bit easier to use. On the other hand, the problem is that you don't necessarily measure the tip and the sleeve resistance independently. And since the sleeve resistance is generally speaking somewhere around 1, 2, 3%, it's a small percentage of your tip resistance, it may not get you necessarily the correct answers because you don't measure them independently, and therefore you cannot size your load cells for that resistance. And that's really what I mean. And here we talk about the susceptibility, but that's really what brings me then to the next part, and that is the rating of the sensors. If you are taking a load cell, then the accuracy is directly related to the full scale output. So if you have a load cell that is suitable for 10 ton, then the accuracy is, say, 1.5% of 10 ton. If you get a load cell that is for 15 ton or 20 ton, and then you get a larger, or the accuracy is not as good. And that is why it's, again, important that you know what kind of job you're doing. If you are in very sensitive soils and very sensitive clays, make sure that you have a load cell that's a little bit more, a smaller scale, so that you have a more accurate response. At the same time, since we're not just measuring the tip and the sleeve friction, we also measure the pore pressure. Make sure that you understand what your pore pressures are going to be, so that you get a pore pressure element that will not get overloaded. Because if you have a sensor that is not suitable for the various values, if it's too small, then it's going to break when you do your testing. It's going to fail, and as a result, you won't get any you don't get any answers. So that's some of the main things that you need to keep in mind. Diameter. If you get started, my recommendation would be start with the 15 centimeter square cone. If you want to play it safe, go with a subtraction type cone, unless you're working in very sensitive soils, sensitive clays or so. Then starting off with a compression cone may be more appropriate. But the subtraction cone definitely is more robust, less prone to damage. And let's talk about what kind of sensors, the ratings of the sensors you need to have. And that's where GeoPoint or Eijkelkamp GeoPoint is more than happy to help you. And you're not alone with this whole thing. And you can always get us or get the information from us and the support that you need to make the choice, the right choice for your application. Now, I know this is a somewhat longer answer. I started off with saying, hey, no, not all cones are created equal. The good thing, though, is when you approach it from a different angle, the cone is so heavily standardized, whether it's by ASTM or the ISO standard. All the dimensions are standardized. The angle of the cone is standardized. The length of the cone is standardized. And that means that the cone, if you get one 10-centimeter square cone or another 10-centimeter square cone, most likely you're going to get the same answers. That's the whole background of CPT, that you have such standardized equipment, such standardized operating procedures that everybody's pushing the cone with the same amount of the same speed into the ground. That way you have a repetitive answer, and in that case cones are created equal because they're heavily standardized and prescribed by the standards. So that's kind of the answer to question number 2 to Mike.
Excellent. When you say sensitive soils, what do you mean? What are you referring to when you say that?
A sensitive soil to me is a soft clay or a silt or something that is softer, doesn't have that much bearing capacity, is not as robust as, say, a very stiff sand. Generally speaking, the sensitive soils to me are the soils that have a lower N value. And then the reason why I say that's more sensitive, because if you have a small change in your bearing capacity there, it's more important to note it because of the foundation that you may want to put there. If you have a stiff sand, you have a robust soil. So that's kind of what we have. And then the other sensitive soils is more like with offshore type applications where you have cementation of the soil that you may break, but that is not encountered all that much on shore.
Okay, excellent. Well, that leads to my third question.
One thing. Before we go with that, Mike, one thing that I want to add to that, and it has nothing to do with necessarily the cones, but when we talk about the cone, we generally talk about the cone that you see there in the picture on the right-hand side. But you could put additional modules behind it. That is it still the same cone? No, but you could put a seismic module, a magnetic module, a video module behind it, and that is an extension of that cone. And that could mean that you could get some options there that you normally don't think about, but that's something to keep in mind as well. Sorry about that.
Okay. Gerald, my next question is, so we're gathering all this information. This cone has given us all this information. What are the advantages and disadvantages with a cable CPT system, with a non-cable CPT system? And before you answer, I'll just say that we're currently running cable, but we are working on, in 2021, we'll have a non-cable system available. But what are the advantages and disadvantages here?
Difficult question to answer, because part of it is what's your personal preference? Obviously, when you have no cable, it's easier to operate the CPT system, or seemingly so, because basically all you have to do is just put the tubes together. You don't have to worry about a cable. The cable fills the inside of the tube. Generally, it's a little bit more hassle. So obviously, when you have no cable, it cannot break. So you have one more item in the field that cannot fail. So you would say, hey, yeah, no cable has all kinds of advantages. But right now, the wireless systems that are in place, that are available, do not necessarily have the bandwidth or the capacity to transmit all the data. And what I mean by that is that if you are using seismic CPT, for instance, you cannot get with a wireless system the data to the surface. It simply is not available. So that's a drawback. The other drawback that you have is as you're going down into the ground and your cone starts to deviate somewhat from the vertical, and therefore your CPT string starts to bow. If it bows too much, you may lose your system. You may lose your signal. And if you do that, then what are you doing? Because it's wireless, you have nothing there to back this whole thing up. And then if you have water in your system, you may have a problem with that. So personally, right now, there is no reliable wireless system that will work in all applications on the market. It's simply not there. Now, as you were mentioning, Mike, we are within Eijkelkamp working on in the final stages of testing and retesting and testing again a different type of system with rechargeable repeaters. You mentioned it, we should have it commercially available in 2021. And the nice thing about that system is going to be that other than the rods itself, the users will have the option to use either a digital system with or without a cable. Let me explain to you how that's going to work. What you see here on the screen, starting on the left-hand side, is a little repeater. It has a rechargeable AAA battery, and it's basically has a receiver on one end and then an optical transmitter on the other end. And the diameter of that little unit is about 15 millimeters, or about 0.6 of an inch, and that is just a little less than the opening in a CPT tube. So what we're doing is and you see it in the middle, on the male end of each CPT tube, that unit is put there, glued there, and it stays there. And then basically what it does, since we will have that similar unit in every single CPT tube, and what you see on the right-hand side is that the CPT cone collects the data, and then these repeaters are sending that signal 1 meter at a time to the next repeater and bring it back to the surface that way. And if you decide to go to a job where you have to do seismic CPT and where a wireless CPT system does not have sufficient capacity, then you decide to use other rods and just use a standard cable that you then connect to your cone. The other problem that you have though with it is that normally the cable not only brings the data from the cone to the surface, it always also sends the power that you need to operate your cone from the surface to the cone. And that means that if you don't have a cable, that you then need to put a power pack or so above your cone. If you don't have that, then obviously your cone will not work, and you have a problem that way. And then, of course, all these repeaters need to be recharged, and we'll probably come up with a system where you put your rods in there when you don't use them, and then make sure that you have sufficient, some kind of a charger that at the time they get recharged, so that before you start doing your next job, everything is there. Personally, one of the things that I still am somewhat concerned about is the whole issue of reliability. If you are doing your CPT sounding and you are about 70 feet in the ground and suddenly something goes wrong, Murphy's Law, it's towards the end, you lose connection or you don't have that anymore, then you have to start all over again. You have to bring your cone back to the surface, try to investigate what's happening, and then you have to push your cone back down again. That's why I'm call me too conservative, but I would still suggest that for most applications, you stick with your wired system with your cables. And also, as I said before, when you do seismic CPT, with seismic CPT, we really need to have a wired system. So those are kind of the issues there, Mike.
Excellent. Do you know, Gerald, if we'll have a chance to test this new system, wireless system, next year here in the U.S.?
Yes, we will make sure. The whole idea has been, and when I got started with Eijkelkamp about a year ago or so, that we would have had lots of demonstration jobs, demonstration events with the CPT equipment. COVID-19 unfortunately has thrown a wrench in all those efforts, but we will have demos where we can show the wireless system and also show how easy it is to switch from a wireless to a wired system, and that you only need to use different tubes, but the rest of your CPT system remains the same.
Okay, fantastic. All right. Well, my next question was, and being in the water industry for many years, what does the presence of the water table, how does the presence of the water table affect CPT?
I like that question, Mike, because it's a simple question. It doesn't. Whether we have it or not, yeah, we will just push through the water table. The only thing, of course, is when you measure your pore pressure, it is nice to know the water pressure, because then underneath that you have the hydrostatic pressure. But other than that, whether we have water or not, it really doesn't affect CPT whatsoever. We can just keep pushing and use the same equipment.
Okay, excellent. And then my final question, because there's many people still running SPT, is not having a soil sample for visual and lab inspection. Is this a disadvantage?
Let me be honest with you. As a convinced conehead, think about it this way. If you put a foundation in the ground, a deep foundation, does that foundation really matter or care whether the soil is red or blue or brown? Does it really matter what the soil, the size of the particles are? All the foundation cares about is how the soil behaves. And that soil behavior you don't necessarily get with a sample. So to me, there's no reason to get that sample out of the ground so that you can touch the soil and smell the soil and all that good stuff. But as I said, I'm a convinced conehead. I believe in the CPT results. If you do want to have a sample with a cone or with a different type of cone that you see on the bottom part of the screen, you can still do that. Basically, what you do is you push the top part that you see in that figure, you push that cone into the ground. Once you've reached the depth, you retract the cone tip, as you see in the middle part of that figure. You then keep pushing the unit deeper in the ground. It fills the sample area, and then you can bring that sample to the surface. So not at the same time that you do your CPT. You push your cone first, and then you push just adjacent to it this dummy cone, and then take samples as much and as often as you would like. Yeah, you can get these samples up to a length of 40 inches, diameter an inch, inch and a half, and in that order of magnitude, and you can bring those samples to the surface. The good thing, though, is that when you are doing it this way compared to SPT, you've done first your cone sounding, so you know what where the layers are that are of interest, and then you bring your sampler back down to those layers, take a sample there, and only bring those samples to the surface, and don't necessarily have to sample everything to figure out what may be of interest. Because let's face it, when you do CPT, you know your soil behavior while you're doing it. You know what you have there. You have a lot more information than when you do SPT. So is not having a soil sample a disadvantage? To me personally, no, it does not. I don't need to feel it. But for those of us that would like to feel the soil with CPT, you can still get a soil sample and bring it to the surface and do all the lab tests on it that you would like to do.
Well, Gerald, I must tell you, I was in preparing some of these questions, I was reading different things, and this was actually a disadvantage from a report, and I didn't see the date till later. 1978, a U.S. highway report on CPT. This was one of their drawbacks. So that's been many, many years ago. And I think a lot more people are more convinced about CPT today than 40 years ago. So.
Well, not only that, also since then we have developed these samplers because there are still people. I always bring it back to how my father-in-law, when I came to the States in the mid '80s, I started using a credit card for everything. I would buy virtually anything on a credit card. He liked cash. He wanted to feel the touch, feel the money. He did not think that plastic was that's not real money. Well, that's how you grow up, what you get used to, and that's still if you're used to working with samples. I can talk to you for an hour, for a day, for a week, but you still want to get those samples. And that's why the CPT industry realized that they need to have a sampling capability, and that's why they come up with these samplers for those of you that want to have a sample. And the other thing that you might want to do is when you're on a job site, as we talked last month with Kevin, or 2 months ago with Kevin, is that you do a whole bunch of CPTs, and in one location, take a few samples as correlation so that you then have a CPT. And your samples, you know that correlate very well, and then you feel more comfortable with the CPT results for the other locations.
Yeah, that's excellent.
Okay, you see here on the screen my email address and then Mike's email address. Please feel free to contact us. And thank you for being here. Thank you for showing interest in Eijkelkamp equipment, and especially, of course, as far as I'm concerned, in CPT equipment. And I look forward to talking to you in the future. Thank you very much.